Today's lesson is 11.7 and 11.9. Our objectives for today are to be able to add and subtract rational expressions and to be able to solve equations with radical expressions. So add and subtract radicals and solve equations with radicals. Radical expressions in which the radicands are alike, meaning exactly the same, can be added or subtracted in the same way that like terms can be added or subtracted. So you don't have to write down this example, but if we have 3 square root of 2 plus 5 square root of 2, since the square roots of 2 are exactly the same, meaning the same index and the same radicand, same index here, same radicand, we can add the outside number. So 3 plus 5 gives us 8. So it's 8 square root of 2. It's basically the same thing as saying 3x plus 5x is 8x. The square root of 2 is the same thing kind of as having a variable there. Here's our first example. Go ahead and write it down. We have 9 square root of 10 minus 4 square root of 10 minus 8 square root of 10. And just like the previous example that we looked at that I didn't make you write down, here we have all square roots of 10. Since they're all square roots and they all have 10 underneath the radical sign, I can add or subtract the outside numbers. So we're going to say 9 minus 4 minus 8. Okay, so we're going to say 9 minus 4 minus 8, and that's going to give us negative 3. So this is going to be negative 3 square root of 10. And that is my final answer. Please make sure you have all of that written down before you move on. Also know that I can check this in my calculator. I can say 9 square root of 10 minus 4 square root of 10. Whoops. Make sure you arrow out of that radical sign. Minus 4 square root of 10. And again, make sure you arrow out. Minus 8 square root of 10. Then it gives me this decimal. If I put in negative 3 square root of 10, I get exactly the same decimal. So that's a way for me to check in my calculator. I can put all of this in at the top, and I can put in whatever I get whenever I simplify and make sure that the two of them match. Alright, go ahead and write down number 2. Number 2 says square root of 7 plus 8 square root of 7x minus 4 square root of 7 plus 6 square root of 7x. And again here, I can add or subtract if they are exactly the same. So here, the square root of 7 and the square root of 7x are not exactly the same because this one has an x and that one doesn't. So I can put together the two square roots of 7, and I can combine those. And since there's nothing in front of this square root, I always put a little 1. So I can go ahead and put my square roots of 7 together because those are exactly the same. So I'm going to say 1 minus 4, and I get negative 3 square root of 7. Again, I just like to kind of mark those out. Then I have 8 square root of 7x and 6 square root of 7x. So I'm going to say 8 plus 6, and that gives me 14. So plus 14 square root of 7x. And that's all that I can do there because I can't put these together because they are not exactly the same. It's like, kind of like terms. It'd be like trying to add an x and a y. You can't do that. So here I can't put together a square root of 7 and a square root of 7x. So please make sure you have all of that written down before you move on. Alright, go ahead and write down number 3. We have 2 square root of 27y minus 3 square root of 3y plus the square root of 48y. Now, so far, up until now, it's been very easy to see whether or not something was the same to see if we could add or subtract them together. Here it's not as easy to see, and the reason being 27 is not simplified and neither is 48. So before I can determine whether or not I can add or subtract them together, I have to simplify the 27 and the 48 by doing the upside down birthday cake. So over here, I'm going to come over here to the side, and I'm going to birthday cake 27. So for 27, again, I have to make sure I'm dividing by primes, and I can't divide by 2, so I'm going to divide by 3. If I divide 27 by 3, I get 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So there's my 27 broken down. I'm also going to come over here. I don't have to birthday cake 3 because it's already prime, but I do need to simplify 48, so I'm going to come over here and upside down birthday cake 48 as well. 48 I can't divide by 2, so I'm going to say 48 divided by 2 is 24. I'm going to say 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. Alright, now that I have them birthday caked, I'm going to go through and write them all out like I would if it was each individual one, like 11, 6, A and B. So I'm going to say, instead of 27, 3 times 3 times 3 minus 3 square root of 3y. Again, I didn't have to do that to the 3 because the 3 was already prime. Plus, and instead of 48, I'm going to say 1, 2, 3, 4 2's and a 3. I also need to make sure and bring that y down. I don't have more than 1, so it just needs to come down with it. So now I'm going to go through and simplify each one. I'm going to start with this one. I'm going to say I have a pair of 3's, and I know I'm looking for pairs because I have an index of 2 if nothing's there. So I have a pair of 3's here. So I'm going to rewrite this as 2 times 3 square root of 3y. Now I'm just going to bring down my minus 3 square root of 3y, because again I don't have to do anything to that one. And over here I have 2 pairs of 2's, so I can bring out 2 2's. So I'm going to say plus 2 times 2, because I can take out 2 2's. And I still have the square root of 3y. Now you can see I'll have all square roots of 3y, so I'm going to be able to add or subtract these together, but I need to go ahead and multiply what I have on the outside first. So here I have 2 times 3. So 6 square root of 3y minus 3 square root of 3y, and then 2 times 2 is 4, so 4 square root of 3y. So now they look just like the other two problems that I did after I get them simplified on their own. So I can go ahead and put these together because they're all square root of 3y. So I'm going to say 6 minus 3 plus 4, and that's going to give me 7. So my final answer is 7 square root of 3y, and the y stays underneath the radical because I didn't have a pair of y's anywhere. So that is my final answer. Please make sure that you have all of that work down before you move on. Alright, go ahead and write down number 4. I have 1/3 square root of 90 minus the square root of 10. Now again, right now the square root of 90 and the square root of 10 do not look the same. However, they haven't both been reduced. So we're going to go over here and reduce 90 and 10, so I'm going to upside down birthday cake 90. So I'm going to say 90 divided by 2, and I get 45. 45 can be divided by 5, and I get 9. I could have also divided 45 by 3 right there. 9 divided by 3 is 3. 3 divided by 3 is 1. So there's my upside down birthday cake for 90. Now if I upside down birthday cake 10, I divide 10 by 2 and I get 5. So I just get 2 and 5. So I'm going to bring down my 1/3, and instead of the square root of 90, I'm going to say 2 times 5 times 3 times 3 minus the square root of 2 times 5 for 10. I'm going to see if I have any pairs that I can circle, and right here I have a pair of 3's, so I can take out a 3. Now don't let the fact that there's a fraction in front, okay, bother you here. It's just going to be 1/3 times 3. Square root of 2 times 5 back together gives me 10. Minus, now here there is no pair, so I just multiply those back together and say square root of 10, except I'm going to put a 1 in front right there. So in my calculator, I'm going to use my alpha y equals, and I'm going to say 1 over 3 times 3, and that gives me 1. So I have 1 square root of 10 minus 1 square root of 10. So since they're both square roots of 10, I can put them together. And when I say 1 minus 1, I get 0. So this entire thing simplifies down to 0. Please make sure that you have everything written down for number 4 before you move on. And again, I could have checked this in my calculator. I could have said alpha y equals 1/3 square root of 90, arrow out of my square root, minus the square root of 10, and it gives me 0. Sorry, move that over so you can see it. So when I put that in, it does give me 0, so I can check it and make sure, just in my calculator. Alright, so there's my first objective. We should now be able to add or subtract radical expressions. Now we're going to solve equations with radical expressions. Alright, so go ahead and write down number 5. We have the square root of 3n equals 6. So here we just have to remember the fact that squaring and square rooting are opposite operations. So if I want to get rid of a squared, I take the square root of both sides. If I want to get rid of a square root, I take the square of both sides. They're opposite operations. So here I have to make sure that there's nothing on the outside of my square root or my radical sign first, and there's not. Everything's underneath it. So I can go ahead and square both sides, because squaring and square rooting are opposite, so it marks out, and I end up with 3n equals 6 squared is 36. And now I just have to finish solving. I'm going to divide both sides by 3, and n equals 12. Okay. I can come over here and check and say the square root of 3 times 12 equals 6. And if I put that into my calculator, I say square root 3 parentheses 12. I'll make it look just the way it looks there, and I hit enter, and I get 6. So it is 6 equals 6. And that checks out. Make sure you have everything written down for number 5 before you move on. All right, go ahead and write down number 6. We have the square root of 8s plus 1 equals 5. So to solve this one, first of all, I need to get the square root or the radical sign by itself, and I do have a plus 1 that's on the outside, so I have to move it first. I can't square both sides until I move everything away from the radical sign. So I need to move that 1. It's a plus 1, so I'm going to subtract 1 first. And I have the square root of 8s equals 4, because 5 minus 1 is 4. Now that the radical sign is completely by itself, I can go ahead and square both sides to get rid of it, because squaring and square rooting are opposites. I'm left with 8s equals 16, because 4 squared is 16. Then I need to get rid of the 8, so I divide, and s equals 2. Again, I can come over here and check it by saying square root of 8 times 2 plus 1 equals 5. And I can plug this into my calculator to check it. I can say square root of 8 parentheses 2. Make sure you arrow out of the radical to do your plus 1, because the plus 1 is not underneath the radical sign. And I get 5. And 5 is what I wanted, so 5 equals 5, and that checks out. Please make sure you have everything written for number 6 before you move on. Okay, go ahead and write down number 7. We have 2 square root of y minus 1 equals 46. Now again, my first step here is to get everything away from this radical symbol. Anything that's not underneath the radical has to be moved first. So this 2 is not underneath the radical, so it needs to be moved. Since it's right next to the radical, it's being multiplied. So first thing I'm going to do is divide both sides by 2, and I get square root of y minus 1 equals 46 divided by 2 is 23. Now that the radical sign is by itself, meaning everything I have left is underneath the radical, I can go ahead and square both sides. My square root and my squared cancel, and I'm left with y minus 1 equals 23 squared. So in my calculator, I'm going to say parentheses 23 squared, and that gives me 500. Oops, let's show you that right fast. 23 squared gives me 529. Now I have to move this minus 1 that's still here. Since I still have a minus 1, I need to move that, so I'm going to add 1 to both sides. And y equals 529 plus 1 gives me 530. So my answer to this one is 530. So I'm going to go through and check it. I'm going to say 2, 530 minus 1 equals 46. I'm going to plug that into my calculator. 2 square root 530 minus 1. Enter, and it gives me 46. So it checks out. And you need to make sure and check these. Every once in a while you'll have what's called an extraneous solution, meaning that you'll be able to solve it, but when you go back to check it, it will not be correct. This usually happens when the radical's by itself and it equals a negative, because there's no number I can take the square root of and get a negative. So you do need to be checking those answers. Make sure you have everything written down for number 7 before you move on. Alright, number 8 says the square root of a plus 5. Be careful, that's an A, not a 9. I know it looks kind of like a 9. It's actually an A. Square root of a plus 5 all over 3 equals 12. And again here I have to get the radical sign by itself, and since the entire radical is being divided by 3, I need to move that 3. So since it's being divided, the opposite of dividing 3 is to multiply both sides by 3. So multiplying by 3 cancels, and I'm left with the square root of a plus 5 equals 12 times 3 is 36. Then I have the radical by itself, so I can go ahead and square both sides to get rid of it. Now be careful, the square and the square root cancel, so I'm left with a plus 5 equals. Now be careful, a lot of times we see this and then we say, oh, the square root of 36 is 6. And we go ahead and keep trying to work it. However, I'm not squaring I'm not taking the square root of 36, I'm squaring 36. So make sure that you're doing what the operation is asking. So I say 36 squared, and I get 1,296. So again, don't just go ahead and say, oh, well, it's obviously 6 because it's 36. We're squaring 36, not taking the square root of it. I still need to move this plus 5, so I'm going to subtract 5, and a equals 1,291. So there's my a. Now that it's by itself, I know I'm finished. I've solved for it. I know what a is equal to. Again, we need to make sure we come over here and check. We have square root of 1,291 plus 5, all divided by 3. We want to make sure that gives us 12. So I'm going to check that in my calculator. Square root 1,291 plus 5. Actually, you know what? I can put all this in at once. If I hit alpha y equals first, then on the top I can hit square root 1,291 plus 5 over 3 and hit enter, and I get 12. So this one does work out. So 12 equals 12, and that checks out. Please make sure you have everything for number 8 written before you move on. Alright, so there is your second objective. You should now be able to solve equations with radical expressions. I need you to go ahead and get out a sheet of paper and go ahead and write down your assignment. It's 11-7, page 837, 16 through 30 evens, 59 through 60, and then on page 854 through 22 evens. So please make sure you have both of those written down. Those are the ones that we will work on tomorrow in class. That way you have it written down and you're ready to get started. We're also going to look at 1 or 2 real-world examples tomorrow in class. This is the end of your video. Thank you for watching.